So today we will be going through the topic of digital twin and lean, how the world is leveraging these newer technologies and what the vision of quality 4.0 or quality 5.0 looks like with utilizing such technologies. Something about myself, I am the ASQ Customer Supply Division newsletter chair, and I'm the SME that supports ASQ Lean Division. I have a decade of experience in medical devices, especially in surgical robotics. And as a side project, I like to work on the upcoming newer technologies and how the quality world is changing. I write some articles and papers about that and do a lot of presentations on this. This presentation in itself was my first presentation at WCQI this year. You are seeing an updated version of that, as well as I have a surprise for you at the end of the presentation. So let's jump into it. What are we trying to achieve through this presentation? We will understand how digital twins contribute to achieving lean supply chains, what are the goals of the lean supply chain, and how we can leverage digital twins to realize that. We will gain some actionable insights into doing this and understand the key quality tools where digital twin technology could add value. So this will be agenda that we will cover today. We will introduce the vision of lean supply chains. We will have an introduction to digital twins and how it helps not just for process efficiency or supply chain and logistics efficiency, but also for quality purposes, how we can realize that. We'll see some implementation strategies, and we'll also go through some published case studies by other experts in the field who have utilized this technology and achieved larger success. So let's jump into it. What does lean supply chain actually mean? So imagine lean supply chain as your perfect diner where everything is just on time. Like there is no wastage of additional pancakes sitting on the table. There is no wastage of syrups, but just the right quantity at the right time, right when you need it. That's what lean supply chain mean. In the manufacturing sense, we try to target the lean setup for raw materials from the supplier, then perform in-house manufacturing, go through distribution and to the customer. All of this is a network which we try to optimize using just-in-time methodologies. What are the core principles driving lean supply chain? The first one is waste reduction. We try to optimize waste as much as possible, be it overproduction or waiting or any form of waste. We would like to reduce it as much as possible. We also target just-in-time of materials or services so that there is no wastage, either something coming too early and sitting in our inventory or coming too late and we're not able to build what we want to build. Continuous improvement. This is a really strong concept that we have been using for decades now. Any work that we do, be it like your professional work in organizations or in your own personal life, the concept of continuous improvement is a living example of how you can achieve lean thinking in your work. And last but not the respect for people. Although this is very less mentioned, it is very much vital. You cannot have any revolution without engaging the people, that is the workforce. You need to respect the people, work with them, and then develop whatever solutions or improvements that you are targeting. So why pursue lean, right? What is the output of this? The output is efficiency and cost reduction. We all strive to optimize the cost as much as possible. So we can do that by identifying the waste and reducing the waste so that we are on a path to less cost or less investment needed, as well as increase the efficiency. Also improve the quality. Like whenever we order something from the supplier, if the supplier follows a certain lean framework, we do have a confidence in the supplier and its products that yes, we will be getting the right quality of product. It also targets agility and responsiveness, like how soon can we respond, and then the sustainability gains coming out of the lean framework. Let's also try to understand this from a tightrope walker analogy, what lean does and how digital twins integrate into it. So Imagine the tightrope being your manufacturing or your servicing organization, and the person being the lean framework. You are very slim and you try to go fast in a certain direction. However, one gust of wind and that person will be wobbling. And that's what we all saw during all the COVID supply chain issues or any other geopolitical issues that come up. Whenever you try to be going for singular supply chains and just in time, the disruption is massive. So here, the pole which the person is using is kind of a balancing pole, which you can think of as resilience, such as you come up with some buffer stock, you come up with some dual sourcing or some robust supply chain management. However, what if I told you that on top of that, let's say if you can get a system where you can sense the gust of the wind coming and then change your position in a certain way that you are able to withstand that gust of wind and still move forward. And that's digital twin for us, right? So let's understand what a digital twin is. It is basically a virtual replica of a physical system or processes continuously updated with real-time data. So think of it as a digital replica of whatever physical products or physical equipments or physical services are out there available. You try to collect the data and use that data to optimize or to simulate. The key components are physical entity that is being modeled here, the digital model that comes out of that physical entity, the data connections, because there is significant number of data point communication in sometimes in millions or trillions of data points that you have to work towards, and the analytics and simulation coming out of it. As the NVIDIA CEO Jensen Huang has said that before you build an AI factory, which is the vision of the industry, where the industry is moving towards, you need to build the digital twin so that you can realize the vision of AI factory. So in the future, everything from factories to cities and even humans will have a digital twin version. So imagine even in the current times, like whosoever is using Apple Watch or any other watch to monitor their health, it is basically a subset digital twin of yourself. You can also consider your phone as your digital twin because a lot of information about you is right there on the phone. And that's where a lot of companies, they target your data so that they can create a digital twin of you, understand what your needs are, and then target you with a certain type advertisement. So a lot of these concepts are already being used, but in manufacturing, this has taken up a lot of interest lately. Digital twins are of various degrees of complexity. The comparatively simpler is the product one. Most of the folks who might have worked in new product development, they would understand how we have already been using certain simulation softwares such as ANSYS or any other simulation software like LabVIEW Simulink for various type of simulation stuff at the product level. So that is one of the simplest means of simulation, which has been in use for decades now. Then comes the process. As we go down, the complexity increases. Product is comparatively simpler. Then comes process, which is slightly challenging. Then comes at a company level. You are just trying to create a digital twin of one company or one site. But much more complex than that is a supply chain network. It has its own share of complexities in terms of trust, in terms of the data that you can share between organizations, the agreement of sharing a certain type of data. So a supply chain network is definitely much more complex. And then the last one is network of networks. So why now? Digital twins, I think, has been in use for decades, as we know, at a product level, right? We all know that a lot of NASA's systems are totally controlled by a control tower on the ground, and then you can control the actual physical device in space, right? So that is sort of a digital twin. So like we had this concept for quite long. So why now? What has changed now to bring this concept so heavily into our use right now, right? So the first one is the IoT and sensor proliferation. For the folks who have been in this industry, like even just a decade ago, we were working with sensors that were quite bulky, costly, as well as the rate at which it would collect the data would be like an hour or a day, right? But compare that to like the current set of sensors, which are so lightweight, has constant communication at a rate which we can't even imagine with the cloud. And also they are cheaper and provides battery for around like multiple years. So a lot of advancements have happened in the recent times, which is currently driving to realize the vision of digital twins. The other thing is big data and cloud computing. If it is a small organization, if they have to set up their own data warehouse, it's so costly. But now with the advent of big data and cloud computing, even a small organization can leverage those big data centers, gather all their data there, use that data to make sense out of it, analyze and create some simulations there. Advanced analytics and AI. This is a really driving factor in the recent times that is giving the required push to this concept of digital twins, where you can use AI to identify certain patterns which you might need weeks or days for someone to do it manually, but then AI can do it in a few minutes or hours. So this is definitely something that is pushing this field forward. And then last is connectivity. As we discussed, right, like a decade back, if you had to connect something, we were talking in terms of like megabytes per second. But now you have a lot of good connectivity where you can go to even like of connectivity and upload and download speeds. So the connectivity has definitely improved a lot and is driving this sector here. So how does digital twins differ from traditional method models, right? So imagine you having a photograph of yourself or your family on a vacation, right? That's a snapshot in time. It does not change once you have created that picture, right? But instead of that, imagine like if you have your Instagram story, right? Like you update it daily and you can also add any filters that you want. So that's the same difference between traditional models and digital twins, where the previous one was a one-time snapshot or limited scenario analysis, often quickly outdated, right? And then the digital twin is continuously updated using the digital systems. It has an adaptive simulation and it looks at a holistic view from end to end. Building trust is very much important. As we are trying to leverage more and more technology, we need stronger governance and security frameworks as well. Building trust through data quality and governance is very much important for folks who work in the regulated industry. You would see a lot of the other industries already going and leveraging this type of technologies, but in the regulated industries, you have to take a step back and see whether this type of technologies are even robust enough to be used, right? Because you will be challenged by the regulation. To do that, you have to build a level of trust, get into the real good data quality, because as that term is very widely respected, garbage in, garbage out. For you to get a good analysis, you need to make sure that whatever data you are feeding in is good quality data. So through frameworks, we do need to start building trust into the digital twin itself. And that's when we'll be able to iterate it and get to a level where we are all comfortable using it. What does this provide? It provides an end-to-end perspective. So imagine watching an ESPN broadcast, but not of a football game, but of your supply chain. You exactly know where all your parts are at what stage, right? And how you can control it. As soon as you identify a certain unexpected event, do you control it or do you have some options to control it? And that's where AI also comes into the picture and machine learning, where it simulates a certain event happening and then comes up with some clear, robust steps forward to pursue that. We saw what are the goals of lean supply chain. We saw what are the capabilities of digital twin. Now let's understand what digital twin and lean supply chain together, the blend of that, how can it help us in realizing the goals of a more optimized supply chain? So the first one is waste reduction. As lean professionals or quality professionals, this is our main goal, right? We do want to reduce waste as much as possible. So in case of a digital twin, you can think of it as without digital twin or such mature systems, what you would do is, as soon as your inspector or somebody would notify you, you would go to the field, look for that product and try to search for that product. In some cases, like you don't even know few days or few hours that a certain product had failed. And by the time you go there, there might be a lot of volume of product that has already been created, and you need to like segregate all of that, secure that, and then take any action. But like with digital twin, if the floor has been updated to a certain level, you get the notification, you already know where that product exactly is, and you just have to go and grab it, right? This tool helps with that just in time, right? This is the most important tool for logistics efficiency, right? You are in control what component or what piece of the puzzle is at what stage and how it would impact your plan of a certain activity. Continuous improvement, as quality folks, this is of much more interest to us. We always want to challenge ourselves as well as our organization to improve on the processes, on the products, right? So digital twin, either through simulation or optimization or just by the sheer amount of data, we are always striving for continuous improvement, right? And quality control, as I mentioned in waste reduction. I think with SPC charts, we do have a certain level of visibility and control already, but this will just give us a larger scale of control, as in you can see the data from your suppliers and make calls out from that in real time, rather than the supplier notifying you through emails and then you going through that in a few days and then responding back to it, right? Real time is the key here. The first two is definitely dependent, very much important for operational efficiency, but the last two is what we as quality folks strive for. Common barriers and how to tackle them. So just like any other technology or a disruption, we always have a certain amount of roadblocks that we have to tackle before we can actually start the process of exploring, learning from it, and then implementing to a large scale, right? So what are the common barriers to this? The first one is cost and complexity. The infrastructure, definitely, although it's not as high cost as if you would do it on site, but even offshore cloud infrastructure usage comes at a cost. So you have to prepare for that. Sensor hardware, although sensor cost has gone down, those same sensors at scale, to realize that cost has to be included skilled personnel. Like either you upgrade your current workforce or you get newer folks to jump into it. I have been quite vocal wherever I give this presentation, even in my own company. Like I am always striving to like upgrading the current workforce, retrain them so that they are the champions. They already have the domain knowledge, right? You just need to motivate them to include more skills so that they can realize the vision of quality 4.0 or 5.0 utilizing newer projects. So cost is definitely a barrier here. Change management. A lot of times we see that any new disruption happens, there's a lot of uncertainty, and through that uncertainty comes resistance, right? So it's very much important to give that confidence to your team members, to identify some champions who can be the lead for this so that there is confidence in the larger team and have them, empower them to drive improvement projects. The other challenge is data in silos, right? And I think we have been facing this for quite a long time. Like as quality professionals, we have always complained that a lot of the data doesn't make sense. Like you would have 100 spreadsheets out there somewhere, but they don't talk to each other. And when you try to make sense out of it, there is no way to connect one data point to other data point, right? Because each team would manage their own different type of systems, right? And have a different sets of criteria. So data being in silos is also a challenge. You need to think from macro level, start to develop your data architecture in such a way that any data point that you can take from anywhere makes sense and connects and can be used with a different type of data set. And scalability, like you don't want to jump into a big scale solution immediately. You should start small, understand that, and then start rolling out to other sides. As we will see in the following slides, how certain companies or certain projects have done this, and gained a lot of value out of it. So digital twin, lean plus digital twin is waste reduction. I'll try to move slightly faster for certain slides so that we can definitely go through the demo and the case studies as well. One of the other thing is to try to be more proactive rather than reactive, right? As you can see from this image itself, and I'm pretty sure whoever folks have worked in the industry for a few years have noticed this, right? When anything breaks down, be it a machine, be it parts delayed from a supplier or a certain issue came up, right? You have to let go of your personal commitments and let go of your work-life balance for that time and try to support the issue to resolve it, right? What digital twin could do is try to move you from a reactive mindset to a proactive mindset where you are in control of all the data and all the events and are able to plan and prioritize that certain manner. So be it inventory waste, transport and waiting, or production bottlenecks, balancing capacity and preventing breakdowns. And this is where I think digital twin is used significantly. Like coming from the medical device industry, I see that at a product level, we have been using this a lot where we try to create a digital twin of any device, right? That's out there to make sure we understand the health of the device, even your iPhone, right? When you open up your iPhone and your battery metrics, it shows you the battery health. That's basically giving you the indication, like what is the health of your battery. And let's say if somebody is monitoring you that battery health for you, that means that they are accessing that data and they are leveraging that data to guide you based on that. So same thing for machines, right? Like our machines can be equipped with various type of sensors. Using those sensors, you move from a static or a fixed PM plan to a dynamic or a proactive PM plan, right? Where you see the performance of certain metrics go down and try to take action rather than at every fixed interval you try to change something. Collaborative quality management. This is where most of the value comes for us as quality professionals. A lot of this digital twin platforms that are out available in the current market, they target the logistics side of digital twin for supply chain. But what I'm trying to project here is try to create something that helps for the quality domain as well. And without a lot of these platforms available out externally, it's your job internally in your company to create such platforms, right? Like as a custom platform and try to realize the value out of it for us as quality professionals. So you could do, through these systems, you get early defect detection, which you can take immediate actions out of it. You are more targeting preventive actions rather than reactive actions, right? Or corrective actions, as we saw in the case of preventive maintenance. You are more proactive, right? Like let's say a supplier has a certain lot being manufactured for you and you have that data somehow connected to your system and that system flags that a certain lot might get delayed, right? Immediately you are putting a new purchase order for an alternate supplier, or if there is an existing PO, you try to see if the other supplier can expedite that, right? So there are several proactive controls on your end to make those calls and not end up receiving the non-conforming product and waste a lot of time, resources, energy there, right? Continuous improvement. This is also very much important to us. And data traceability. Anybody working in regulated industries would realize or correlate with this point a lot. Anytime you get an auditor, this is one of the main things that they are looking for. Like where is the data and how can you trace that data with whatever you have in the field, right? So that helps. And one of the case study directly targets this and they realize the gains out of it. Collaborative quality management. This is a very important concept in a sense that you will face a lot of challenges head on because no supplier wants to trust you with their data, right? And let's be honest, we can visualize as much as we can, but unless we put that into implementation, there is no real value out of it, right? Gain your supplier's trust. Try to get as much data as they can get you and try to create value out of it. And once you show that value, that's when you will have bigger trust from your supplier to create a real system that is built on these principles. It cannot be a one-way street. It cannot be that We just require the data from our suppliers, but don't share any data from us to them. A lot of time the suppliers are interested on learning how their products are performing against other suppliers in our system for our goal. So you can try to leverage that and share that data while requesting their data to realize this vision of digital supply chain. Butterfly effect. And I think this is really very important in supply chains, that small causes can create big impacts, right? As we saw during COVID supply chains, right? Like even a small foundry or a small raw material plant would get disrupted, and that would impact not just one or 10 organizations, but like hundreds and thousands of organizations all over the world, right? So currently, the supply chain is a very complex, interconnected network, and we should be planning. After this learnings, we definitely should be planning much better so that we don't end up in the same scenario again. Like definitely there will be disruption, but as much we can minimize the disruption, that we will gain from it, right? Another thing is Murphy's Law. Plan for the unexpected. Like anything that can go wrong will go wrong. Digital twins realize, like all the simulations that such platforms do, they go with the assumption that such a failure mode could happen or such an event could happen. And what will be the steps we can take at that time when such a step happens, right? So that's one of the goals for this, and improving quality and supplier relationships. These are some of the implementation strategies. I'll share the slides with you guys. You can go through that. Like all this says is start with a foundation. It's very important to understand where you are, right? Your current state, as well as what your goals are. Start small. And once you have the goals cited, establish the technical backbone. What are the critical machines or logistics so you want to monitor through this? What are the systems? Like we work with a lot of systems in our organizations. We work with ERP, MES, QMS, PLM, supplier portals, logistics trackers, right? All of that are in like silos. They are like talking about different things in different languages, right? We need to like pull all of them together to make sense out of it. And that's where data architecture comes into the play, connecting everything together and realizing the digital twin out of it. So where does the digital twin get its data? Is through ERP, MES, the warehouse system, QMS, even publicly available data, right? Like weather, traffic, market demand, and so on. So start small, scale quickly. And yeah, this is a very important key topic, is that collaboration is very important. Like a lot of times what we do is, since this is a largely IT project, right? We just give them the goals and dump the whole project on them, right? But that is a recipe for disaster, because this is something new that the whole community, quality community, or the organizations are trying to achieve, right? To do this, you need active involvement from all the stakeholders. You can't leave quality professionals behind. You can't leave supply chain professionals behind. And definitely you need the suppliers. Like without the suppliers, you would never be able to realize this, right? So collaboration is the key, and every stakeholder needs to be. So I tried to create a very small prototype on my own for a certain use case. This is not at all robust enough what you would see in the platforms that are currently available, right? On the logistics side, those platforms are really good and you can utilize that on the get-go. But on the quality side, like I think we internal custom platforms are the path forward. But I'll just give you a demo on what I created to showcase how a digital twin would look like. So here we see a digital twin simulation for a logistics use case, which is for PO scheduling, where we see that there are parts and the products made out of those parts from the supplier. And here we see that once the order was placed, a certain parts, like for a certain assembly, certain number of parts were placed on order from the supplier. As we go forward, some of the parts are in work in progress, some are in transit, some are in receiving, right? As we notice that we received the parts and some went through inspection, we placed a periodic PO so that we get another work order completed, right? And then once we have enough parts, we start manufacturing the work order. Yeah. So one work order is already on track. So basically, this is just a very basic example of what a digital twin could look like in terms of supply chain. And this is a very basic case, but this gives you an insight into what in-house developed use cases you could work towards, right? And my target is to go for the actual quality use cases, which I'm still working on. Once they are ready, I'll definitely share those as well going forward. And I just saw a message like which tool I use this for. This UI was based on some random wrapper UI, but the backend was created in Python. Even there, I'm not a coder, but I'm learning through using AI. So that also helps a lot of us now using the power of AI, not just to leverage AI for our day-to-day work, but also to create such tools is also something that we can look forward to. So there are 3 case studies that I had found when I was developing this for WCQI, and which clearly showcases how companies have been using such tools to achieve the goals that they strive for, right? So the first one is about a pharmaceutical industry where a certain company partnered with a certain big pharmaceutical company to create data architecture. Basically, what challenge they had was that whenever syringe, sorry, this is for like packaged syringes. So whenever they used to like send out the syringes in the field, there was no clear way of marking for UDI, like unique identification, and tracing that throughout from start to finish. So they partnered with a certain big pharmaceutical company and tried to create a system based on blockchain where for the same unit of syringe packaging, they are able to access and add data to it right from the start of the manufacturing to distribution to the end use of at the hospitals, right? And by connecting all of this together, they were able to create a very robust life cycle of each product that they ship out in the field and be able to lower the risk of contamination and errors. Mars is a well-known company in the confectionery and pet food. They also utilize digital twins significantly to reduce their overfill events and improve throughput. Even if their digital twin was so successful that they utilized it in multiple different sites. So this is what we learned from all this in the presentation today. And the surprise that I mentioned is that I am trying to also create a part 2 of this presentation at WCQI this year, where we will understand what are the data of interest to us for realizing these goals, how we can connect those data points, what is the end goal out of it, and how we can make sense out of it. So yeah, thank you for attending the session.
There was one question about being able to retrofit older equipment.
That is always the challenge. So like most of our equipments, right, they were not, like most of the older equipments, they were not created in keeping in mind the IoT sensors or devices that we have today, right? So definitely there is a curve there. Either you try to get new equipment, or there are some devices that are available currently which you could leverage by that has an open protocol. So then you can like have it as a connecting device between one equipment and the other equipment, right? So let's say, for example, like, thanks all, thanks Manny.
Okay.
Thanks.
Nice job. Okay. See you, Dave. Thanks.